Hello friends, today's question: if m is the mass of the water that rises in the capillary tube of radius r, then the mass of water which will rise in the capillary tube of radius 2r. So in this case we have two capillaries, one is having radius r, another having as a radius 2r, and we have to find out what will the mass of water that is going to rise which is having the radius 2r. So this is directly based on the capillary tube rise formula. So we can start from there right away. You can say the capillary rise equation that is given as H is equal to, we have 2t cos of theta, and this is rho g r, where T is the surface tension, T is the surface tension, rho is the density of liquid, theta is the angle of contact, and r is the radius of capillary tube, r is radius of capillary tube, and g is the acceleration due to gravity. So we have to write the formula in formation of the mass, because everything is asked in the mass. We can write that mass of the water that rises in the capillary tube with radius r, and that is given as m, and m is equal to rho multiplied by v, where v is the volume of the liquid, v is the volume of the liquid in the capillary tube, and volume can be written as H into A, where A is the area of cross section. You can write that volume V is equal to H multiplied by A, where A is the area of cross section, and H is the height through which the water rises. H is equal to height through which the water rises, and this area of cross section can be written in the form of a radius. So we can say A can be written as pi r square. So therefore we can write that mass is equal to rho multiplied by H into A, which is equal to rho H multiplied by pi r square. So here we substitute value of H, that is the height. So we get mass is equal to rho, and H was our 2t cos of theta divided by rho g r multiplied by pi r square. Here rho cancel and this goes with this square, So we are left with 2t cos of theta divided by g. So this is pi is also there, and multiply by r. So all these parameters, variables in the bracket, are constant. Pi is constant. Once the liquid has been decided, that's water, T is constant, angle of contact will be constant, and G will be constant. So therefore we can write from here that M is directly proportional to R. M is directly proportional to R. Now if the radius is changed to 2r, so you can say when the radius is, when the radius is 2r, the mass of water that rises in the capillary tube is, let us suppose, M prime. So therefore we can say, based on this very equation, that M is directly proportional to R. So therefore we can say that M prime is directly proportional to 2R. We can say that M prime is directly proportional to 2R. So we can write that M prime upon M is equal to 2R upon R, where R and R cancels out. Therefore we get M prime is equal to 2 times M. So as the radius becomes twice, mass also doubles. So this is the mass of the water which will rise in the capillary tube when the radius is 2r. This is the mass of the water which will rise when the radius of capillary tube is 2r. And the options that are available to us, you can see that option number A is the correct option. So we can write option A is correct. So this completes the question. Thank you.